In this video, I'll be explaining question 1 of homework 5. So we are given that x and y are independent with PDF of x and PDF of y given as follows, and we are given that z equals to x plus y. So we need to find PDF of z, first by convolution method and second by geometric method. So first of all, to start off with the convolution method, we'll shift left by 1. This will cause our PDF of x to be changed as follows. So initially it's u of x minus 1 minus u of x minus 2. On shifting left by 1, we'll get u of x minus u of x minus 1, and PDF of y will be same as before. Whatever is result that we'll get after convolution method, we'll have to shift that to right by 1 since we are shifting it to left initially. So from convolution method, we know that PDF of z equals to PDF of x convoluted with PDF of y, and on substituting in the given formula for convolution, we'll get the function as follows. Here we can see that so this is this is PDF of x at alpha and PDF of y at z minus alpha, and we'll integrate it from minus infinity to infinity. Now we can split these into 4 terms. So these are the 4 terms that we'll get after multiplying the given integral. And so for the first terms, we can see that since it is unit step of alpha times unit step of z minus alpha, the value of alpha can range from 0 to z, because for other values the integral will be equal to 0. Similarly, for the second term, the non-zero value will be from 0 to z minus 1, and so on for the other integrals. Now when we calculate further, we can see that the first integral can be calculated as z times u of z minus 0, which is upper limit minus lower limit, minus for the second term it will be z minus 1, integral of 1 from 0 to z minus 1 will be z minus 1 times u of upper limit minus lower limit, and so on for the other terms. So when we try to plot the graph for this, we get this graph where we can see that for z less than equal to 0, it is 0. For z between 0 to 1, the graph is z. From 1 to 2, it is minus z plus 2, so negative slope. And for z greater than 2, it is 0. Now this is the result that we got after shifting to left by 1. Now we'll shift back the result to right by 1 to get the final answer, and so that will be basically this is being shifted by 1 to the right. So we'll get z minus 1 u of z minus 1 minus 2 of z minus 2 u z minus 2 plus z minus 3 u of z minus 3. And if we see, we can also shift the graph to right by 1. So originally it was from 0 to 2. Now the graph is spanned from 1 to 3, and the y-axis values will remain the same. Now for geometric method, we'll again perform the shifting to left. So again we have PDF of x and PDF of y given as follows. Now we know that the CDF of Z can be written as probability of Z less than equal to small z, which is probability of Z is equal to x plus y, so it will be x plus y less than equal to Z. Now there can be the following cases. So the first case is when Z is less than equal to 1. In that case, our x graph will look like this. So if we plot x plus y equals to Z, it will look somewhat like this, because we are considering Z to be less than equal to 1. So now to find the CDF of Z, which is probability of big Z less than equal to small z, is equal to probability of x plus y is less than equal to Z, which is equal to the area of this shaded triangle, which is half Z square. Now to find the PDF, we can simply differentiate the CDF with respect to Z, and this will be equal to simply Z. Now when Z is from 1 to 2, the graph will look somewhat like this, where we can see that Z is greater than 1, but it will be less than 2. So in that case, we need to find the area of this shaded region to be able to calculate the probability of x plus y is less than equal to Z, which is uh, given by this shaded region. So the area can be calculated as area of triangle AOB minus area of triangle ACD minus area of triangle EFB. And since these two triangles are same, we can say that it is area of triangle AOB minus 2 times area of triangle ACD. So the area of the bigger triangle is half Z square, and the area of the two smaller triangles are 1 by 2 Z minus 1 whole square, because this is Z and this is 1, so this will be Z minus 1 and this side will be Z minus 1, and twice of this because we have two of these. And when we calculate, we can find the CDF as follows. Now to find the PDF, we can differentiate the CDF and we'll get it as minus Z plus 2. Now considering the third case where Z is greater than 2, in that case we know that since the probability density function sum up to 1, the CDF sum up to 1, so we can simply say that CDF will be equals to 1 for Z greater than 2, and the PDF can be calculated by differentiating CDF with respect to Z, which will be equal to 0. So again we get the same graph as result, which is actually shifted to left by 1. So to get the final answer, we'll shift the graph by to right by 1. So this is the final graph that we get.